Hello students, I hope that you are good, well and fine. Today we will be seeing the solutions for a miscellaneous exercise for this chapter determinant. Okay, so far we have finished all the theory, all the exercise, NCERT exercise of this chapter, chapter number 4 determinants. Now we are at now miscellaneous exercise. Then this chapter will be finished. Okay, so the first problem for this miscellaneous is that we have to show or prove the determinant for this is independent of theta. So let me just show you the properties. So before going to this solving this problem, so this let me just first of all give you the meaning what this means. Independent of theta means after evaluating this determinant, you will find the determinant of this matrix A. If this is your A matrix, then this will be something, yes, some expression or some expression in terms of some expression in terms of x, and it could be some expression just a number, it could be just a number. Okay, clear? So this means that here whatever the expression, whatever the number you will get, here you will not have theta. Okay, in terms of theta you will not get. So that's what it is written over here, that independent of theta, that whatever thing you will find out will be independent of theta. There will be no theta here. Okay, now let me just show you or just recall you some properties of determinant. Okay, which helps you to find determinant quickly. Determinant. So one is this, that if you have A matrix and if you multiply a row or a column. I'm just talking about a single row or a single column. Okay, a column or a column. Then the determinant will be, the new matrix determinant will be what? K times of determinant A. This thing will happen. Okay, if you multiply whole matrix with A, then if you multiply whole matrix with any scalar k, then determinant will be, then new determinant will be, then new determinant will be what? K power whatever the order we have. Okay, K power order means this must be square matrix. Okay, so n cross n, suppose n cross n, so K power n and determinant of A, then new determinant will be this. Okay, simple. Now if you have A and suppose some n cross n, okay, and if you swap means interchange, if you interchange any two rows or column, swap means this thing. So swap or interchange any two rows or column, then new determinant will be is equals to minus times of determinant A. That's it. If suppose A matrix is your A, B, C, D, E, F, GHI like this. And if you swap what two rows, any two rows, suppose now after swapping two rows, after interchanging two rows, suppose last two rows you interchange GHI DEF, then this determinant, this matrix determinant will be equals to minus of determinant of A. That's it. So for example, in case of 2, let me show you A, B, C, D. You know that determinant is AD minus BC. Yes, and now just swap it. Okay, so new matrix will be, so after interchanging CD by CD first row and AB second row, this determinant will be what? As you can see, BC minus AD, and this is just nothing minus of AD minus BC, and this is just nothing but minus of determinant of A, as you can see. Okay, so this is very interesting and very important property. Clear? Okay. Now, the third one is also very important. If you add any row with multiple of other row, okay, the same thing will happen for column. If you want to column, if you add any row with multiple of other row, then determinant remains same, nothing changed, determinant remains same. So what this means, let me give you example in case of 2 cross 2. So suppose ADBC, you all know determinant is AD minus BC. Yes, sorry, the ABCD, the determinant is AD minus BC. Okay, now what you did is quite simple, that you wrote your second row as what? So R2, so you did row operation, that's it. So R2 will be what? R1, say what you can say R2 plus 2 times of R1, this thing, you did this thing. So this means what? Your row 2 will be R2 plus 2 times of this, so C plus 2A, D plus 2B. Now what will be your determinant? As you can see, AD plus 2BA, AD plus 2BA minus, okay, BC plus 2AB, BC plus 2AB, as you can see. Now just see that you will get AD plus 2BA minus BC minus 2BA or AB. This will get cancelled. You only left with AD minus BC, which is the same as this determinant. Okay, so third property, third theorem says that this is, all these are just theorems you will be learning in further or in BSc classes. Okay, I'll be doing here so that you can get quick answers for your question in what? In exams, in competitive exams like this. Okay, so we will be using this in whole of our miscellaneous exercise. Clear? So this will be easy to find. So how this will impact our calculation, you will see. So one way to find the determinant is very easy. You have to expand along rows or columns. Okay, now as you just saw the what theorem, so theorem says, as you all know, theorem says that if you swap, then determinant will be negative. If you row operate, then remains unchanged. If you multiply with a row, then it will be multiple determinant, new determinant will be multiple of the old determinant. Okay, so now, okay, I'll be doing what? So here I'll be just approaching the old way, which is, I hope that you already know. Okay, so just expand, so plus x Okay, I am expanding along column 1 plus sin theta plus cos theta, sorry. Okay, now eliminate this and this, you will have minus x square minus 1. For this, you have to eliminate this. You have x sin theta minus cos theta. Okay, now eliminate this, you will have sin theta plus x cos theta. Simple. Now from this, what you will have, as you can see, minus of x square plus 1. Okay, plus sin square theta x sin square theta minus sin theta cos theta. Okay, plus cos theta sin theta. Okay, cos theta sin theta. This is sin theta plus x cos square theta. Okay, this and this will be cancelled. Taking sin square, taking x and x common from here, what you will have, minus of x square plus 1. Taking x common, you will have, sorry, plus x common, you will have sin square plus cos square, and you know that sin square theta plus cos square theta will always be 1. So this means just 1. So you will have your nice expression as this. So your determinant will be taking again x common, what you will have, or you can take minus x common, you will have what? Or just multiply things, doesn't matter. So x cube minus x plus x. So this will cancel. You have just minus of x cube. Okay, you will have what? Just minus of x cube. So this, your determinant is having no term with theta. So this means it is independent of theta. Okay, clear? Okay, so far so good. Very easy problem. Now here, as you can see, what is happening? Okay, so I'll be expanding along this column. Why? Because it is having a 0. So this, so sign will be, as you all know, this position is 1 3. This means 1 plus 3 will be even. So plus minus plus. So this means minus sin alpha, 0 will be vanished, plus minus plus. So this will be plus cos alpha. Now simple. Now eliminate this, you will have this going to multiply with this, means sin minus sin alpha sin square beta. Now this going to multiply this minus of sin alpha cos square beta. Okay, now eliminate this. So this going to multiply with this, cos alpha multiply with cos square beta. Now multiply with this minus minus plus cos alpha sin square beta. Now take cos alpha common. So taking cos alpha common, you will have here cos square alpha, and here cos square beta plus sin square beta will give you 1. Okay, will give you 1. So far so good. Now taking minus sin alpha, what you will have, taking minus sin alpha, so it will be plus. So taking minus sin alpha, it will be this. So this will be what? Sin square theta plus cos square theta, 1. Okay, 1. Now you eventually you are having sin square alpha plus cos square alpha, which is going to be equal to 1. So this means the determinant for this will be just 1. Okay, very easy, simple. So determinant of this will be 1. Okay, now this problem, so here we have to evaluate this determinant. So here we will be using not the conventional way but the properties. So what I will be doing, I will be adding water, I will be adding rows. So what I will be doing, R1 will be R1 plus R2 plus R3, R1 plus R2 plus R3. So what I will make, x plus y plus x plus y. So I will have 2 times of x plus y here. Same thing will be here. Adding these, what you will have, x plus, So 2 times of x plus y, and the same thing will I get x plus 2y. Simple. So x plus y, x plus y, x, y. Simple. Now, as you all know, in determinants, you can take what? This is what? Same thing written over here. Means I can take this thing as common in determinants. Okay, so this will be common. So 2 times of x plus y, this will be 1, this will be 1, this will be 1. What property I am using? If A is your matrix and you multiply with K with any row, okay, with any row, then new determinant will be K times of this thing. So what I did is just this thing, because this was multiplying with the first row. Yes. Okay, now I will make zeros as much as I could. Okay, I will be making maximum 0 as much as I could, because maximum 0 will lead me the easier calculation. So what I will do, now this is done. So for making 0, what I will do is quite simple. Now I will be performing column. Okay, so this means C2 will be C2 minus C1, and C3 will be C3 minus C1. So this means this column going to minus. So 1 minus 1 will give you 0. This minus this, you will have just x. This minus this, you will have just minus y. This minus this, you will have 0. X minus y, you will have this. This minus this, you will have just what? You will have just x. Okay, as we have y here, so this you will have x. Simple. Now we will evaluate our determinant quite simply. Just okay. So plus minus plus, this will be vanished. You have 2 times of x plus y multiply with, so this whole going to multiply with plus 1 minus 0 plus 0. So this will be directly vanished. So 1, eliminate this and this, you will have x square minus y, you will have this thing. Yes, you will have such thing. Okay. Now this means what? 2 times of x plus y, 2 times of x plus y, x square plus xy. Okay. Clear? Oh, I think here it was minus xy, because y minus this thing, you will get minus of x. Okay. So this means minus x square. Okay. And it will be plus y, x minus y. So this means yx minus y square. Okay, you will have this. So this means just nothing, taking minus common, you will have x square y square minus xy. And this is what? All you know is a cube minus b cube can be rewritten as a minus b, or a plus b cube can be rewritten as a plus b, a square minus ab. Yes. So this is what it is written over here. So your form will be 2 times of x cube plus y cube. So your determinant will be minus of 2x cube plus y cube. Okay, minus of 2 times x cube plus y cube. Please do verify if I'm getting the correct or not. Okay, I hope that it is the correct answer. So using your property, you will get the determinant correct. Now let me move next. Now the sixth, the same approach we will do. Okay, so try to make here, we will try to make, we already have 1, so we will try to make zeros. So how we are going to make? Quite simple. R2 will be R2 minus R1, and R3 will be R3 minus R1. So this means 1xy, the first row will be untouched, but second and third row are going to change. So this means 0. This minus this, you will have this 0, 0, 0. And this minus this, you will have x. As you can see, many zeros. You will get your answer as what? So let's see. So expand along this column. So you will have determinant is equals to +1 minus 0 plus 0. So this will be directly just vanished. You have to eliminate this column and this row. You have x, y. Just your determinant means your determinant will be this x, y. So see how quickly you have evaluated your determinant. Okay, if you are going to through the conventional way, you have to select these entries and then eliminate the respective columns and row, and then multiply and then simplify it, and then you will get your answer. Here, by just doing these two simple things or making maximum 0 as you could, you will get your answer efficiently. Okay, let us move to the next problem, problem number 7. So this problem says we have to solve this system, okay, using the matrix method. Okay, matrix method says that x is equals to A inverse of B. So here what, so we already know that if our system is like this, ax plus by plus c is equals to d1 and like d3. So we used x, y and z. Yes, here you got 1 by x, 1 by y. So how you are going to solve it? Quite simple. You just take 1 by x as what can you say, p. Okay, take 1 by y as q or say r. Okay, so take this as r, this as s, and 1 by z as t. Let me just take p q r. Okay, p q r. Simple. Okay, now your system will be, or just take ABC, that this will be very easy, ABC. Now your system will be twice of A plus 3 times of B plus 10 times of C is equals to 4. This will be 4A minus 6B plus 5C is equals to 1, and 6A plus 9B minus 20C is equals to 2. Now you can solve for this. Solving this means ABC, this will be A inverse multiply with 4, 1, 2. If you get ABC, then you can put your AB value here, and from here you can get your x, y, z values, as x will be 1 by A, y will be 1 by B, and z will be 1 by C. And A, B, C will be coming from this thing. Okay, I hope that you can do it very easily. Okay, as I'm not going to solve it for you, I provided the method, so I hope that you can do it. Okay, so the main thing was to change this system in this following manner. So I did. Okay, now let us move to the next problem, problem number 8. Problem number 8. So we have to here so we have to find the inverse. That's it. If x, y, z are non-zero, then we have to find the inverse of matrix. So what matrix? This matrix, and choose the correct option. Okay, so matrix is given x, y, x 0, 0, 0, y 0. So this means x 0, 0, 0, y 0, 0, 0, z. This is what our matrix. Okay, this is what our matrix. Now I want a matrix here such that this will be 1 0 0 0 1 0 0 0 1. Yes or not? I want this thing. Yes. So work smartly. I'm not going to evaluate A inverse by using row elementary operation or by using adjoint method or any other method. I will be just finding the inverse by using the simple matrix product. How? Suppose B matrix, this is A, this is B, and this is your identity. You all know, or you can say this is your A inverse. You have to find this A inverse. So quite simple. Suppose the entries will be like this: A, B, C, D, E, F, G, H, I. These will be the entries. Okay, so we have to find the A, B, C, D, these values. Okay, that's it. Okay, so let me just multiply it. This going to multiply with this. What you will have? we all know that it is equals to 100,010,001. Okay, this will be just x a, yes, other. Okay, now this going to multiply with this will be bx, this will be cx, as you can see. Now for a second, this going to multiply with this, you will have a yd, ye, yf. As you can see, this going to multiply this 0 yf, I times 0, you will eventually have just yf. Now this going to multiply with this will be zg, this will be zh, and this will be zi. Now here you have 3 cross 3 matrix, here you have 3 cross 3 matrix, and both of the matrix are equal. Yes, this means this entry must be same as this. Okay, this entry must be same as this. Yes, so from this what you can say is that let me write where. Okay, so let me just make some space over here. So okay, now be careful. So bx, this entry will be same as this corresponding entry. This means bx is equals to 0. So this means what? And one information is very clear, that x, y, z are non-zero. This means x is not equals to 0, y is not equals to 0, z is not equals to 0. So this means if x, y, or z are non-zeros, that means divide by x, I can divide by x both sides, you will get this, and this is equals to this. So this means b is 0. So b is 0. Okay, so far so good. We got that b is 0. So this entry will be 0. The same thing will be applied over here. So cx is also 0. We already have x is not 0. So this means c is also 0. So c is 0. This thing also gives me that y is non-zero. We already know that x, y, z are non-zero. So this means d is all 0. So d 0. Here yf, this means f will be 0. H will be 0. So ZH, okay, sorry, H will be 0. Comparing this to this, you will have G will be 0. Okay, G will be 0. Now you are only left with what entry? AEE. So in order to find AEI, so compare this to this. Okay, so this means this means XA is equals to 1. This means A will be 1 by X. So A will be just 1 by X. Okay, compare this to this. This means E will be 1 by Y and I will be 1 by Z. Okay, so this means 1 by Y, 1 by Z. Now, in other words, this is just nothing, X inverse Y power minus 1, or the reciprocal thing, Z inverse. So your A inverse will be this thing. You have just evaluated A inverse by just doing simple comparison and simple product, matrix product. So your option, what? This option A will be your correct option. Clear? Very easy. Okay, let us move to the next problem, the final problem for this miscellaneous exercise. Ninth problem. Okay, so ninth problem says that if A is this, then we have to choose the correct option, and the options depends on the determinant. Okay, so we have to find the determinant first. So simple. So how we are going to find the determinant? The main thing, I'm going to the expanding or the finding out the determinant using the conventional method. Okay, along with this column. So plus 1 minus sine theta will be plus sine theta, and plus of this will be this thing. Okay, now eliminate this. What you will have? 1 minus plus sine square theta. Okay, now for this I have to eliminate this sine theta and minus plus, so sine theta. Simple. Now I have to eliminate this sine square theta minus 1. Simple. Now just simplify it, you will get your determinant. So 1 plus sine square theta plus 2 sine square theta minus sine square theta plus 1. So this will be, as you can see, this are going to cancel with this, and you will have 2 plus 2 sine square theta. This means 2 times of 1 plus sine square theta. And you all know that sine theta will always be less than equals to 1 and greater than equals to -1. And if you square it, you all know that square value, if you have 0 to 1, this means your square will also be 0 to 1. Okay, this means what? How we get this? Quite simple. If you try to see, pick any number in between -1 to 0, -1 to 1. First of all, it will be positive thing. Yes, if you square it, it will be positive. And the second foremost thing is that you cannot exceed this 1. Okay. Okay, whenever you square, you cannot exceed this. Clear? Okay. So this. Now what? Now add 1 to both sides. You will have this. Okay, you will have this. Adding 1. Now you got this. Now just multiply 2. What you will have 2. Multiply with 2. Okay, multiply with 2. You will have this sort of thing. So this means your this thing, this what is your, this is your determinant of A. Determinant of A must not get greater than 4 and less than 2. So your option D, as you can see, equality, this means closed interval 0 to 4. So your option D for 9th will be the correct option. Okay, I hope that you got how we get the this thing, this inequality. Okay, let me once again give you. Okay, so sine theta, you all know, is less than equals to 1 and greater than equals to -1. Break it into two parts. Suppose this is in this way. Okay, so this means sine theta is negative. So square it. What you will have? A square of negative number is will be always positive. So sine square theta will be positive. Okay, but how greater it can be, as we have least value as -1. -1 square you will get 1. So maximum to maximum you can get up to 1. That's it. Now what else? Take another case. So this means 0 greater than sine theta will be less than equals to 1. Okay, so one case is this, another case is this. This thing will be broken into two pieces. One is negative, one is positive. Okay, now this will be what? If you square it, it is already positive. The maximum value is 1. So this means if you square any number from 0 to 1, the square will also be in this interval. Okay, the square will also be in this interval. So as you can see, sine square theta is still in 0 to 1 and sine square theta is still in 0 to 1. So that's mean that eventually we will get this thing. Now what we did, we just added 1 to every side and then multiply with 2. So you get 2 less than determinant of A less than 4. This. Okay. So that's why option D is correct. So I hope that you understood the properties, how we use the properties of determinant to find easily or easy method to find the determinant. Okay, and how we did that? By just making more or maximum zeros as we could. Okay, so please go through these problems once again. This will make you comfortable and will make boost your confidence. So thank you all. We will be back with more interesting problems and more theory. Okay, so again, thank you.